We will now be joined by Arthy Loganathan, who has been involved with quality engineering, test automation, and continuous integration for about 12 years in the industry. She enjoys coding and learning new skills from day to day activities. And she joins us today to share her thoughts on how Red Hat Openshift Data Science fits in everyone's AI ML journey. Without much further ado, let's call upon to our screens Miss Arthy Loganathan.
Hello, everyone. Thanks for providing this opportunity to present my talk on building smarter AI/ML apps with OpenShift Data Science. I am Arthy Loganathan, Senior Quality Engineer at Red Hat, and I will show quick agenda of this talk. What I want you to experience today is from this task is that how can we make data scientists' lives easier? So how can we make their work more efficient? And how can we get that work that they produce to integrate into applications? To do that, first, let's start off with an overview of machine learning workflow, then use cases to perform AI/ML ops with OpenShift Data Science. And I will walk through a case study on the user's experience with OpenShift Data Science. Okay, so let's go on with the slides. We are at a stage where almost every organization is trying to incorporate AI/ML into their product. Let me think about what it takes machine learning into an application. We can think of that these are the four main stages that are involved in developing an application that contains data science or machine learning components. These four stages are implemented as a combined effort of data scientist and the application developer. There are some pain points that we see when teams of data scientists and application developers started to implement the workflow. Just think about what it takes to get machine learning into an application. Answer is that we can think about it through these four stages. So it begins with gathering and preparing data and exploring that data, making sure that it is accessible. So, your data might be anywhere. You have to gather and federate it. You might be dealing with streams as well. So you have got to explore your data, carry out future engineering techniques to extract information from the data. The data you have got may have unwanted stuff. You have to determine what is that you want and what is not. And once you have done using techniques, then as a next step, you can go ahead and think about training or working with a machine learning model, meaning to allowing that model to learn some underlying parameters based on the data that you needed. Now, once I have got a model as a data scientist, we just deploy it in an application. Simple, right? Application developer creates an application that contains this machine learning component. And once that application is up and running, we need to continuously monitor and manage it. Usually, when there is no intelligence component, when things break out, we get an error message or your system stops working. Whereas machine learning components, they will continue to spit out predictions It just happens that the prediction might become wrong more often. So this could be due to model drift or data drift, where the data that you have trained the model on is no longer representative of the data you are seeing in the real world. A data scientist takes care of gathering, preparing data, and then carrying out feature engineering and deploying that model. And they are fine to monitor the model detect. But this drift causes to update the model again. So after doing the modification by data scientist, redeploying that model in an application, we need a application developer's help to get that working, right? So these applications need to be built by cross-functional teams in order to make successful deployments. And it is complicated for a few reasons, not just because of the communication that needs to happen, uh, but it is a bit complicated. One reason it is tricky is that data scientists likes to work on their own laptops, right? As we all do. But this is not ideal due to its CPU and storage space. It lets push data scientists to the cloud world where they can get access to the hardware they need. They can see, use more storage. You can access that sensitive data that is behind companies' firewalls. I think, in general, incorporating data science into applications, isn't it straightforward? Is the tool set that data scientists like to use in daily work, like to work in Jupyter notebooks. Application developers, when they get a notebook from a data scientist, that while trying to convert into an intelligent application, you know, there is a bunch of dependency installations. There is no version locking for those. And so trying to set out the important dependencies is absolutely a real challenge. So the work that data scientists do usually are not conducive to just kind of lifting that code and sticking it straight into an application. So how can we do a better job at that here? Any guess? We can solve this by using Openshift Data Science, which is a new managed service from Red Hat. So this is targeted at data scientists and anybody involved in the development and management of intelligent applications. The couple of bottlenecks that data scientists always face is getting started to self-service, repeatable, or shareable environment and getting into production. OpenShift Data Science allows you to create an environment like Jupyter Notebook as a service. It fits for, I don't want to spend more time in setting things. I just want to push one button to have an environment that is built to suit the work I do. So it obviously suits this use case. So you can operationalize data science by creating an interface, a service endpoint for your models, and you access them from anywhere. So this is the model lifecycle. You can use these services as per your need throughout the model lifecycle. You can use Apache Kafka and Starburst Galaxy for extracting and transform data. And you can use Jupyter Lab, Anaconda, OpenShift Data Science for running experiments and to create model. And also you have OpenVino AI Analytics Toolkit for deploying models as service. And again, you can use Openshift Data Science and Openshift API management for monitoring models and to track the performance. So Red Hat Openshift Data Science provides a platform for data scientists to use their favorite tools to create any real-world AML solutions. It is based on the open source project Open Data Hub. And Open Data Hub is you can think it of as a blueprint for building an AI as a service platform on Kubernetes-based OpenShift container platform and Ceph object storage. This service allows data scientists to develop, train, test, and deploy machine learning models using source to image feature, and it has a Jupyter notebook and core libraries such as TensorFlow, PyTorch, etc. And it allows you to access third-party tools by 30 plus partners. It is a fully managed cloud service for OpenShift that promises to deliver an advanced yet simplified machine learning experience on the OpenShift platform. The idea is to provide data scientists with more customizable machine learning platform compared to other existing alternatives that restrict them to use a very specific set of tools. It is an open workflow platform that includes Jupyter notebooks and common frameworks such as PyTorch and TensorFlow. And it is also complemented by accessing to certified partner technologies from Red Hat's marketplace. It can be thought of as a fully integrated machine learning model development environment that provides easy access to various useful tools from third parties. So I will walk through a case study on how easily one can start off with OpenShift Data Science. Imagine that you are an administrator working for Visa, and you have a group of data scientists who wants to develop a solution to the data fraud for credit cards. At first, you need an OpenShift cluster to get started. And once purchased, OpenShift Data Science tile will be visible, and it is available in your clusters add-on tab. You have to click install, and once it is done, you will find that data science operator is installed. Then you have to click the dashboard. You will see enabled and explore tabs. Moving on to the next slide. There, if you click explore section, all third-party tools are visible to use along with OpenShift Data Science. So, for example, users can access services that make it possible to optimize and tailor their machine learning models behavior on Intel Corporation hardware using the Intel OpenVino for Enterprise Toolkit. Then they can also access the Intel One API AI Analytics Toolkit, which provides various tools and frameworks needed to extract the insights from models and optimize their performance on Intel central processing units. So we can say data scientists have integrated access to the tools and frameworks needed to build and deploy their model, as well as helping delivering high performance on Intel hardware. And another key launch partner is NVIDIA Corporation, whose graphics processing units serve as an ideal engine for more demanding AI and machine learning models. This integration will enable accelerated computing, giving data scientists the ability to scale computationally expensive neural networks to large, complex architectures without compromising the productivity. So, in other words, data scientists will be able to reduce the time it takes to train their models by throwing more resources behind them with minimal coding changes required. Another integrations include Anaconda's popular data science platform and IBM Corporation's Watson Studio with Auto AI, which makes it easier to build, run, and manage AI models at scale. Also, Selden Technologies, Selden deploy tool, which can be used by data scientists to refine their machine learning deployment models. And Starburst Data, Starburst Galaxy platform for data analytics. You can integrate with these partner solutions. And if you click enabled, so far everything is in Explore tab. And when you click enabled option, then by default, Jupyter Hub tile is found. So let's go and start a Jupyter Hub. It provides Jupyter notebooks in the Jupyter Lab interface with several out-of-the-box notebook images that automatically include common libraries and packages such as TensorFlow, PyTorch, Scikit-learn, Pandas, NumPy, and others. Versions of these packages are regularly updated in these images to make it easy for the data scientists to get started and stay updated. Also, it allows developers to bring experimental models to production faster with minimal obstacles. Leveraging core OpenShift technologies like source to image, S2I, you can host models on OpenShift dedicated platform for easy testing or export them out in a containerized format for use in on-premises or edge or any cloud applications. First, going on to the next slide, I can pick a notebook image from a list of notebook images here. I'm going to include PyTorch or maybe TensorFlow. So my notebook will automatically include TensorFlow and other plugins for my project. You can also pick resource setting for your notebook that includes CPU, memory, and GPU as well. The environment section is used to load dynamic variables that you don't want to save in the notebook. For example, what you can use is you can give secret access keys for S3 bucket in the environment section so that it will not be get saved in your notebook. Then once you have entered all the data, start the notebook server. Once it is started, and then you can experiment with your notebook. So by providing a unified self-service sandbox environment with integrated tooling and access to a range of open source data science projects and proprietary software, it enables data scientists to focus on their tasks at hand and develop and train models rapidly in a more secure and supported environment. For instance, Openshift Data Science enables Jupyter Lab service by default, so that allowing users to develop models and implement analytic techniques in Jupyter notebooks. With a range of tried and tested notebook images to choose from, users can quickly load container images and develop models using the latest frameworks, including TensorFlow and PyTorch. And with the ability to connect to GPUs on demand, model training and testing can be accelerated, so that reducing the time needed to develop models and gain insights. This helps to rapid prototyping and experimentation use cases. So in a nutshell, OpenShift Data Science helps to overcome complexities of wiring together the necessary data sources with diverse model training and model development technologies to begin harnessing the full potential of machine learning in trusted open source technology. Any questions? And that's it. If you have any questions, please feel free to reach out to me. And thanks to you.